In a world increasingly shaped by artificial intelligence, stealth technology, and precision warfare, Britain is stepping into the global spotlight with its most ambitious aviation project to date, the Tempest fighter jet. This sixth-generation aircraft is not merely a successor to the Eurofighter Typhoon, it's a symbol of technological ambition, international cooperation, and future-forward air dominance. With years of planning, billions in investment, and a powerful coalition of allied nations, the Tempest aims to reshape the landscape of modern air combat. The race for supremacy in the skies. Military powers across the globe are now competing to field the most advanced sixth-generation aircraft, while the United States has long led the fighter jet frontier with platforms like the F-22 Raptor and the F-35 Lightning II. Other nations are pushing aggressively into the arena. China's J-20 is already patrolling airspace, while Russia has showcased its Su-57 prototype. Britain, however, is determined not to trail behind. The Tempest project is designed to place the UK at the cutting edge of aerial warfare, combining revolutionary propulsion, next-level stealth, and artificial intelligence into a single lethal package. A name that carries legacy and vision. The name Tempest holds historical weight in British aviation. During World War II, the original Hawker Tempest helped counter German air power and turned the tide in Europe. That aircraft replaced the older Hawker Typhoon, bringing renewed force to British skies. Today, history echoes forward. With the Typhoon fighter nearing the end of its service life, the Tempest is stepping up, not as a relic of the past, but as a future-defining marvel. It will not only replace the Typhoon in the Royal Air Force's inventory, but will redefine Britain's aerial combat capabilities for decades to come. Post-Brexit push for sovereignty in industry. After Brexit, the United Kingdom found itself outside the European Union's defense and aerospace frameworks. France, as the EU's remaining nuclear power and aerospace leader, assumed a dominant position on the continent. In response, Britain focused on building its own independent defense posture. The Tempest emerged from the 2015 Strategic Defense Review, where the government laid out a roadmap for the Future Combat Air System Technology Initiative. This was not only a military venture, but a socio-economic one, meant to support local industries, develop technical skills, and ensure the UK's defense manufacturing capabilities remained robust and independent. Farnborough unveiling and the dream taking shape. The Tempest project made its public debut at the Farnborough International Air Show in July 2018. UK Defense Secretary Gavin Williamson revealed a full-scale model of the jet, showcasing its delta wings, twin outward-canted vertical stabilizers, and stealth-optimized form. The aircraft's design pointed clearly toward the future, incorporating low observable features from nose to tail. Behind the presentation stood a formidable industrial team. BAE Systems took the lead on the overall project, with MBDA developing the weapon systems. Leonardo UK joined to create avionics and sensor technologies, while Rolls-Royce took on the challenge of designing an entirely new generation of engines. To support this endeavor, the UK government pledged more than $2.6 billion in funding to carry the aircraft through the development phase. Flexibility through modularity. What truly sets the Tempest apart from many other fighters is its modular, plug-and-play design. Engineers have created a platform that can be customized for different missions by rapidly swapping out sensors, weapon systems, and even fuel configurations. This modular architecture will allow the aircraft to remain adaptable as technology evolves, ensuring its relevance over several decades without requiring a full redesign. Moreover, approximately 30% of the jet's structure will be produced using 3D printing techniques. These additive manufacturing methods allow for complex, lightweight parts to be created with precision, speed, and minimal waste, offering both production efficiency and engineering flexibility. Stealth by design. The Tempest's stealth capabilities are built into every inch of its structure. Its subtly raised rear fuselage houses smooth, S-shaped air ducts that hide heat and reduce the radar signature. Engine inlets are seamlessly integrated into the body to avoid radar hotspots, while internal fuel and weapons bays preserve the aircraft's streamlined exterior. All of this contributes to a significantly reduced radar cross-section and infrared profile, making it difficult for enemy sensors to detect or target. While this internal storage increases the aircraft's weight, that burden is balanced by the tremendous thrust being developed in its next-generation engines. A new era in propulsion. Rolls-Royce is leading the charge to develop an engine unlike any currently in service. The Tempest will require an extraordinary amount of onboard power, estimated at 1 megawatt, to support its radar, avionics, cooling systems, and potentially even directed energy weapons. That's 10 times more than what the current Eurofighter Typhoon generates. To achieve this, Rolls-Royce is incorporating a revolutionary embedded starter generator directly into the engine core, known as the E2SG. This innovation eliminates the need for a bulky gearbox and enables both engine start and power generation from a single internal source. The engine will also manage its heat output smartly, doubling as a power plant and a thermal management system. This integrated design allows the Tempest to operate stealthily by masking heat emissions, a common vulnerability in stealth aircraft. Intelligence in the cockpit. Inside the Tempest, the pilot will not fly alone. The aircraft will be equipped with an artificial intelligence-driven co-pilot system capable of assisting with decision-making and reacting to threats faster than a human could. In extreme scenarios such as high-G maneuvers that may incapacitate a pilot, the AI will take over instantly to keep the aircraft on course. Leonardo UK is developing a suite of electronic systems that includes digital beamforming radar capable of scanning multiple targets simultaneously, wideband RF sensors that adapt in real time, and advanced data fusion techniques. All sensor inputs, from radar to infrared to offboard drones, will be unified into a single data stream. This enables superior situational awareness and target tracking, and an augmented reality interface will project key information directly into the pilot's view via helmet displays. Advanced weapons and loyal wingmen. Though official weapons loadout figures have not been disclosed, experts suggest the Tempest will carry between 6 and 8 air-to-air missiles internally, preserving its stealth form. One of the signature weapons under development is the JAM missile, a collaboration between Japan and the UK. It fuses Mitsubishi Electric's Seeker technology with MBDA's Meteor ramjet propulsion, resulting in a long-range missile with high speed, accuracy, and target tracking abilities. Beyond this, the Tempest may be equipped with future cruise missiles designed for long-range strikes against ships or fortified ground targets, likely successors to the Storm Shadow Scalp family. Yet the most futuristic addition may be the use of loyal wingmen, unmanned drones that fly alongside the Tempest, undertaking dangerous missions like jamming, reconnaissance, and even launching their own missiles. These expendable units provide tactical flexibility while reducing risks to human pilots. Global partnerships and the Tempest Consortium. To accelerate progress and reduce costs, the UK formed an international partnership now known as the Tempest Consortium. Alongside BAE, Rolls-Royce, Leonardo, and MBDA, several other major players have joined, including GE UK, GKN Aerospace, Martin Baker, Collins Aerospace, Thales UK, Kinetic, and Spirit Aerosystems. Each company contributes specialized expertise from airframe design to sensor integration and safety systems. The UK also signed formal agreements with Italy and Sweden in 2020, outlining shared responsibilities in funding and technological development. Japan followed with its contribution to radar and engine testing through the Jaguar demonstrator project. By pooling global talent and resources, the consortium aims to bring more than 60 breakthrough technologies to maturity for the Tempest fighter. Prototypes, testing, and what comes next. The Tempest is projected to cost the UK over $8.3 billion through its development phase. While substantial, this figure is modest when compared to similar US projects, such as the B-21 Raider, estimated at $29.5 billion. British defense officials have emphasized the importance of rapid development and cost-effective production. To that end, the first flying prototype is expected to take off by 2027. Engineers at BAE Systems in Preston, England, are already fabricating key components, and early flight trials will offer insights into aerodynamics, radar absorption, propulsion, and electronics well before the aircraft enters full-scale production. The target is for the Tempest to be fully operational in RAF service by 2035, giving the military ample time to train personnel, upgrade infrastructure, and refine tactics suited for a stealth-enabled AI-supported fighter. And that's a wrap on Britain's Tempest, the storm that's set to rule the skies. If you enjoyed this deep dive, don't forget to give this video a thumbs up and hit that subscribe so you never miss a flight with us into the future of defense and aviation. Thanks for watching, and until next time, keep your eyes on the skies.